So this presentation is basically how we developed it, how we developed the systems behind a lot of the GIS, BIM, reality modeler, and the latest survey technology. Basically, many of you know, and many of you use the first MRT line. The current line being built is the MRT line 2 called SSP. And as you can see, the length, the number of stations, and the daily ridership projected. So the SBK line has been completed, and the SSP line should complete by 2022. And currently, we have just finished the final design of all the stations, tunnels, and it's at final approval, final design. Construction has started, tunneling has started, and we use a lot of technology basically to not only shorten the time frame, but also to improve on cost, and also to help with the quality of work. It also reduces a lot of the safety incidents. So technology is all throughout this SSP line, right from design into construction. So many of you would have heard what is BIM and how this technology is being used in construction. We are one of the first, if not the first, to use BIM in a full scale in an enlarged infrastructure project in Malaysia, and if not in the region, because what we're doing is an integration of tunnels, stations, systems, all integrated within a holistic environment. So there is process, people, and technology when it comes to BIM. We have to follow very strict construction standards, methods and procedures laid out by the government as well as MRTC. We have to be BIM certified and follow the BIM certification and workflow process, which actually basically involves a lot of change management and checking of models. We also do integrated field data capture together with, linked it together with planning and commercial. We also have changed a lot of the culture in the company when you use BIM, because traditionally engineers, architects always use 2D, but in BIM we are using a lot of 3D, and together with this 3D you get databases that you can link with other systems. So this is the advantage. It's something very new, very challenging for our local engineers, mainly because they don't learn this in university, but when they come to our company, they need to pick this up very fast. With technology, we are also doing virtual modeling, virtual rooms, virtual meetings, where architects, engineers, planners, they all sit around in the same room working on these models. Why are we doing it? Basically, you can see up there is time saving, cost benefit, and quality improvement. So this is an example of how a BIM model, if you're looking at this for the first time, BIM has been around, 3D in design has been around for a long time. When I was in university in '95, we already had 3D. But what's the difference with 3D then and 3D now is basically the 3D comes with a large database behind it. So every material, equipment, all comes with attached metadata and workflows that you attach that in the BIM process. So what you see in the image here is they have three main fields. One is called architecture. The other one is MEP, mechanical, electrical, plumbing, and the third one is structure. So that's normally the civil guys. So what you see is a combination of all three, and then what we build is a single integrated model. And what this allows us to do is to build our buildings faster, with less problems, and with better quality. And we are one of the first, if not the first in Malaysia to do this. So how is GIS coming into this whole environment? Now, GIS also, when I was in university, was mainly 2D, right? And it was basically used by cadastre, utilities, and databases have come a long way since then. And what we find is an integration between BIM and GIS, and this is happening right now. I think in the last 2 years, if you read what Esri is doing and all the other vendors like Bentley, they're integrating GIS and BIM together. And as part of the MRT project, and in the contract by the government, we need to set up an enterprise GIS platform in the cloud. And it has to be a centralized hub that can be shared this throughout the web. So what you have for basically those guys in the at site and MRT officials is they don't have the 3D software. They want to see it on the web. So this is where we are the first to develop this in Malaysia as well. So BIM with GIS comes in, we've designed this in the last 2 years in design phase, construction phase, and operation phase, which is maintenance. So as you can see on your screens, the design phase is a lot of quality check and correcting a lot of the design issues. Construction is at site, a lot of work that happens at site, and a lot of issues that we collect from site, integrated with planning and commercial issues. And finally is the operation, which is the maintenance. These are the questions that were raised by the different business units, and some of which you should raise in your own company or department as well. What are the issues you're trying to solve? What are the technical challenges? What are the type of people you need? How do you train your staff? How do you improve them and make them use the system? It's fine if you build a great system, but if nobody is using it, then what's the point? This is the key question we need to ask in all our GIS or BIM project. How efficient are we using the systems that we are building? Whether it's benefiting anybody, whether it's reducing cost, improving quality. So, what we have discovered in our data is a lot of software, mainly from Autodesk, Bentley, from Esri, and we integrate 2D data, 2D engineering data that includes satellite images, LiDAR, 2D CAD, a lot of CAD drawings, a lot of utility drawings, existing utility drawings. We also get survey drawings, topo drawings, elevations, cadastre, and we integrate that together in the BIM model. Then we have, of course, the 3D models, which is the 3D Revit models, the UAV drone 3D models, the 3D laser point cloud, which we do, TLS, and together with the TBM, which is the tunnel boring machine integration systems. So this is two systems that we develop purely web to display our data. The 2D basically is all the CAD data, all the engineering data. And the 3D is all our BIM, Revit, and tunnel data that is published in the web. This is pure web. There's no plugin. This is using WebGL technology. These are examples of how it looks like in the web. You have drone, you have TLS, which is laser scan, and you have BIM models. All the models here you're seeing are all running on pure web browser. We are the first to do it. And how do we acquire the data? We use, of course, many of you also are familiar with, is the 3D point cloud and drone acquisition. We use very high-end 3D survey equipment. Our internal survey department does this for us. They use a lot of very high-end equipment to capture the data, correct the data, and then use it with our local projection to calibrate with our local projection with height and with height information, especially since we are working with mean sea level. So it's Selangor Kertau datum, WGS. So many projections, we are integrating it into one. This is a perfect example of an actual work that is being done, right? So the design engineers, the architects, and the site people will use the drone data and also the TLS data, laser scan data, in a single software to check the model as the construction is going on. So you are checking your model, your design against what's happening at site right now. And I have to mention a little bit about the technology we are using. We are a Microsoft Azure based house, so we use all their web servers, and the cloud service is based on Microsoft Azure. I don't manage this myself. We engaged Microsoft Gold Partner to create these servers, but we then install and configure everything on our own. This is the future, and this is something that everybody should learn, and I hope everybody takes away something from this. The cloud technology is here. You reduce a lot of on-premise issues. You don't have to have, backup issues. You don't have to have virus issues. You don't have to have patching issues. It's always well maintained, and the speed performance, they monitor it. If they're slow, they will increase it. So all these issues are basically handled by Microsoft Azure themselves. It's fantastic. Just recently, in the last 4 months, I developed, with my team, of course, I'm the development lead for the BIM GIS team, so I handle almost all the development work for this. This is the mobile field construction that we just developed in the last 4 months. And what we do is we integrate all site data, so there's no hard copy paper on site. We're using tablets. And we integrate that with our BIM model, and that integrates with the GIS. All drawings, maps are on your tablet. Site engineers, supervisors, subcontractors, they all are currently using. So we have 3 stations live now using this, from permits, safety permits, to lifting permits, to excavation work, QA, QC, and any operation site daily reports is done on tablet right now. And these are real pictures that we are showing right now. This is in Kampong Baru station, one of our underground stations. And these are forms that are being created on site, and it's live. It's also running on cloud computing. We analyze this data. We pick up issues on site, which is if there's any defect, any problem, let's say, for example, concreting problem, excavation problem, foundation problems. We pick it up on site real time so that guys in the office can actually work on it and improve it. So that you remove a lot of postmen, a lot of people that goes back and forth doing nothing, you remove a lot with cloud computing. And in a way, you upskill people. Digital transformation is also digital disruption. So you need to manage people on site, manage people in the office. A lot of them are just, very manual work. They expect that to be, the same for the next few years. It's not. It's changing. It's here. Mobile technology and digital disruption is here. And it's also improving the quality of our work. And part of the digital transformation is also better safety at site. We fill up forms, do audits, and we share these audits real time with the government agencies. And we also build dashboard systems, reporting, and this is very, very important because the trend is a lot of analytics, big data analytics. You're doing reporting, progress reports, and management reports and KPI tracking. So we build this. We built a lot of the reporting tools using open source technology. So maybe after this, if you want, we can have a discussion offline about the different tools and technologies we use. A lot of open source technology we use, and it's really, really useful. It saves costs as well. Part of this, we achieved some international awards, one of which was the Bentley Infrastructure Award. We beat a company from China for this. Very proud of that. Among the many awards that we received is mainly because of the integration of BIM, GIS, survey, and actually seeing the results on site and also the progress that we are doing with the MRT Line 2 project. So with that, I'll just play one short video. Hopefully it works. You can capture that link there on YouTube. It's on YouTube as well, so I'll just...
The Klang Valley Mass Rapid Transit, or KVMRT, is an infrastructure project that consists of 3 different lines, connecting the city and its surrounding. The second MRT line, the Sungai Buloh Serdang Putrajaya, or SSP line, is 51 kilometers with 37 stations. To manage this large-scale infrastructure project, MMC Gamuda has adopted new technologies.
The construction industry has changed hugely in the last 20 years, certainly from my experience, working with essentially 2D data to today where we're using 3D virtual models.
One such technology implemented is the Building Information Modeling, or BIM.
BIM actually stands for Building Information Modeling, whereby you manage your information throughout the construction life cycles. So you bring information from the design stage up to the construction stage, up to the facility management stage.
All information related to the project is stored digitally in a cloud-based platform called the Common Data Environment, or CDE, and is accessible to all relevant parties.
We have a big network of consultants that cover the structural design, the M&E design and the architectural design. It's a big network of people coming together on a single platform.
For a mega project like the KVMRT, one of the main challenges is to ensure seamless information exchange and real-time collaboration between the various parties involved, especially during the design stage.
What actually BIM does, actually he helps during the design process, whereby we can visualize it very well. So we can have this design efficiency or accuracy from the design side.
BIM uses sophisticated computer software that involves 3-dimensional or 3D imaging to plan and design any construction project. The teams will conduct a virtual design review, or VDR, where they can review the compatibility of the various design elements.
You can eliminate design errors, you can reduce times and then reduce the cost of the constructions.
Besides the 3D modeling system, MMC Gamuda also incorporated the elements of time and cost. This enables the construction program to be visualized virtually and to check that the construction complies within the intended time and costing. Another innovative use of BIM is the point cloud validation, a 3D laser scanning method that is carried out on site.
We have a piece of equipment that fires a laser beam many thousands of times and captures site structures, site components very quickly and very efficiently into a digital content. We then take that content and we can incorporate that into our digital models, our 3D models, to be able to check and validate what's been constructed.
This project also uses the Geographical Information System, or GIS, an advanced mapping tool designed to capture, store, analyze, and present geographical data.
The objective is to capture data that's relevant to SSP line, but on a mapping level. So we take multiple photographs with the drone. We capture all the station locations. We capture data that relative to the alignment, and using some sophisticated software that executes algorithms, it overlays the photographs. You can develop a 3D model.
As BIM is a relative.
I think I'll stop here. You can see in YouTube where the link is, and maybe you can just watch it after this. Okay? So thank you very much.